All right, we're going to take a look at the sandwich theorem. Ran out of time in class, so I'm going to make a quick video here. The sandwich theorem basically is a way we can evaluate a limit of some functions that otherwise we wouldn't be able to. The situation that we'll be able to use it for is a situation where we have three functions that we know where one of the functions, in this case f of x, the one we're trying to find the limit of, is always, for all x, going to be less than the value of the function g of x. So no matter what x value I pick, at that x value, the y value for f of x, or the y value for f, is going to be less than the y value for g. And at the same time, the value at that x value for f will be larger than the value for the function h. So in other words, f of x is always in between the two functions. So we see here f of x is greater than or equal to h of x, and at the same time less than or equal to g of x for every x value. And if that's true, then the limit of these three functions at any value of x will also be in the same order. In other words, the limit as x approaches 0 of f of x will be greater than or equal to the limit of h of x as x approaches 0. And it'll also be less than or equal to the limit of g of x as x approaches 0. And it doesn't just have to be 0. This I actually probably should have said as x approaches any value c right here. X approaches c, I should have probably put that. I just put 0 because that's the one we're going to be doing, but it's for any value. So I'm just going to not mess with that right now, but here's the value. Here's a problem that we're going to show as an example. The nice thing for you is that on a test, we're always going to tell you that you are going to be using the sandwich theorem. In other words, find the limit using the sandwich theorem. And you're also always going to be dealing with a trig function. And the nice thing about that is on these trig functions, we know that the sine or the cosine function is always going to have an output value between -1 and 1. So for this problem, we know that the value of the function sine of 1 over x is going to be less than or equal to 1 and greater than or equal to -1. And because x squared is always greater than 0, we can multiply any time you have an inequality like this. If you multiply all three numbers by a positive number, it's going to stay in that order. So I can multiply -1 times x squared, and that's going to stay less than or equal to x squared times the sine of 1 over x, and that's going to stay less than or equal to x squared times 1. And so now we have -x squared less than or equal to x squared, the sine, I messed up there, sorry, x squared times the sine of 1 over x, which is less than or equal to x squared. So now, if that's true, then the limit as x approaches 0 of -x squared is going to be less than or equal to the limit as x approaches 0 of the sine of 1 over x, which is going to be less than or equal to the limit as x approaches 0 of x squared. Now, we can evaluate the limit as x approaches 0 of -x squared because we use the simple method of substitution. If you plug a 0 in for x, you get 0. So this limit is 0. We cannot plug in, there's supposed to be an x squared right there. I messed up. And this is going to be x squared sine of 1 over x. And I'm having some troubles here. X squared sine of 1 over x, and that's going to be less than or equal to, what the heck's going on here with this Apple Pencil, less than or equal to, and again, on here, I can find the limit of this function, limit as x goes to 0 of x squared. By substitution, we plug in a 0, and we get 0. So now it's pretty simple. The limit of what I'm supposed to find here the limit is x goes to 0 of x squared sine of 1 over x. It's greater than or equal to 0, and it's also less than or equal to 0, which means it has to be 0. So the limit as x goes to 0 of x squared sine of 1 over x is equal to 0. And that's what we call the squeeze theorem or the sandwich theorem.